All right. Today we're going to talk about 3.9. 3.9 is the go. 3.9 the go. It's just on the back of 3.8. We talked about 3.8 yesterday. 3.9 on the back. All right. I'm not sure why I didn't do the ready to set or the go in 3.9 or the notes, but I'd have to go look, and I'm not going to go do that right now. The main focus, what I decided was, we're going to look at the go, and the topic is solving quadratic equations. And it says use the discriminant to determine the nature of roots of the quadratic equation. Well, first of all, what is the discriminant? The discriminant is the radical, b squared minus 4ac. They call that the discriminant. Why? I don't know, they just do. Right? We're going to use this part, the discriminant, to determine the nature of the roots. What do we mean by the nature of the roots? The nature of the roots are solutions. In other words, if we take a quadratic function and we go ahead and we solve it, what are its roots? What are its solutions? Again, another mathematical term you should know, roots or solutions. And we would go ahead, and this would be factorable. So we would say x plus 2, x plus 3, so minus 3 and 0, minus 2 and 0. Those are the solutions or the roots to solving that quadratic function. If I can't factor it, let's say this was 7, not factorable, now I have to use the quadratic formula, and this discriminant right here would tell me the nature of the solutions. You have to go back and remember, in a quadratic we have 3 scenarios for solutions. Those 3 scenarios are as such. The very first solution is that I have 2 x-intercepts. These would have 2 roots. Okay? So 2 roots or solutions. Here, where I have the 1 x-intercept, it's 2 roots, but it's essentially 1 intercept. And I say it's 2 roots because this is something where you would get a repeated factor. Right? Technically it has 2 roots, but it's the same root, so it only has 1 x-intercept. And then we get something like this, and I've talked to you about this before, where we get 0 intercepts. It's Friday, I can't even spell. I'm just going to do ints, okay? 0 ints. This is what we would call a complex solution, okay? It's dealing with imaginary numbers, all right? I'm not going to touch too heavily on that in this class, but we have 3 solutions. This discriminant right here will tell me what of these 3 it is. There's only 3. It will tell me. So if we look at, what is that, 26. It looks like it's number 6, but it's 26. All right, the 2 got cut off there. So all I'm going to be focused on, first of all, is listing A, B, and C. All right, for number 26. A is 1, B is -5, and C is 7. And then I'm going to go ahead and I'm going to use just the discriminant part. Okay, that's the focus of this, just the discriminant. Minus B, minus 4, A, C. And I'm going to simplify this, and I'll go ahead and substitute my values in. B is -5, A, 4 times A is 1, C is 7. And then I'm going to simplify this. I don't worry about the minus B or the 2A. Not worried about it. Why? Because, again, we'll be able to tell one of these 3 just from this. So I'm going to simplify. The square root of, well, -5 squared. Again, remember, -5 squared is not 5 times 2, and it doesn't end up in a negative. -5 squared is positive. A negative times a negative is positive 25. Is it positive 25 minus or plus? Well, a negative times a positive is negative. Negative times a positive is negative. So it's 25 minus. 4 times 1 is 4. 4 times 7, last time I checked, is 28. And we go ahead and we simplify. And what do we get? We get -3. Now, we haven't talked a whole lot about this, but a negative radical. We cannot take the square root of a negative radical. It doesn't work. So when you get a negative radical, you end up with what we call complex solutions. Okay? we end up with complex solutions. However this would work out over here, this minus b and the 2a and everything else, I know that if I have a negative radical right here, my solution is complex. I'm done. That's all they wanted me to determine. All right? So let's look at 27. I'm going to erase this, so if you need to, you can pause and go back and look at it. All right? And I'm going to look at 27, and I'll tell you, let's just look at that. We get 27, we get A is 1, we get B is -5, and we get C is 6. Okay? So the only difference between the last problem and this problem is the C value is 6. All right? And we're going to watch what happens. Again, focusing only on the discriminant. Minus 5 minus 4 times A, which is 1, times C, which is 6. Again, the only difference is this 6 right here. How does that affect the radical or the discriminant? Well, 25 minus, because a negative times a positive is negative, a negative times a positive is negative. 6 times 4 is 24. And this simplifies to the square root of 1. Well, first of all, it's a positive radical, so I can get a decimal out of that. Right? If I fix everything. Not only that, the square root of 1 is 1, which is an actual whole number. So I can get a whole number. Okay. So whatever this ends up working out to be, yeah, I might end up with some fractions. I might end up with some decimals. That's okay. But I'm going to end up with 2 roots. Why? Because the plus or minus. Remember the plus or minus out there? The plus or minus 1? Whatever the b value is and whatever the number is underneath here, I'm going to end up with 2 solutions. So these are what we call real. All right? I'm just going to keep it simple. It's actually real and, well, we have real and we have, I'm trying to think of it now. We have real solutions that are, I can't even think of the word. Rational or irrational. This would be a real and a rational solution because, and I'm not worried about the rational or irrational. The only difference is rational is like an actual physical whole number. Irrational means decimals. That's what that means. I'm more worried about real or complex. So if you get 1 repeated factor, that's real. And I'll even put that up here. Okay, this would be real. This would be real. This one down here is complex. All right. So visually, if you get a negative radical, it's going to look something like this. If you get a real solution, it's going to be something like one of these 2. That's it. It's just complex or real. Those are the only 2 things. All right. And that's what we're going to work on. And then on 35 through 38, which looks like 5, 36, 7, and 38, which is actually 38 through 38. It says solve the quadratic equation below using an appropriate method. No, I want you to use the quadratic formula on all of those. Just practice it again. There's only 4 of them. And in fact, for those of you that are viewing, let's see. Let's do this. Use the discriminant to determine the nature of the roots. There's 3, 6, 9. There's 9 of those. No, we can do all 9 of those. If we're going to do all 9 of 26 to 34, let's do... It's Friday. You pick and choose. Since I'm having you do the quadratic formula, you pick 2. Any 2 you want to do on the bottom there, for those of you that are viewing, any 2, I don't care, but show your work. Again, no work, no credit. All right, so any 2 at the bottom. Ask questions, please. Be ready for a quiz next week.